Okay, sorry, I'm trying this new software, so we got cut off. So maltose was the last one we were talking about as far as disaccharides, because disaccharides again make up two monosaccharides. So here we have the disaccharides. We see sucrose and how it's linked with two. Oligosaccharides, short chains, three or more. Polysaccharides, those are the very large one, at least 50. Glycogen is the stored version of glucose. So you think about after you've eaten something, let's say something very fatty. We talked about a pizza place, Mama Pizza or Mama Mia's. And after you eat that pizza, you have overabundance of glucose. What the body tends to do is store it as a glycogen in the muscles so that when the body is in need of energy, it can just break it down from there. Starch, we find that in a lot of potatoes, a lot of carbohydrates, and of course cellulose, which we see in celery. I don't know how many of you all like celery, don't like celery. It's hard for our body to digest, but what we do see is it does have a lot of water in it and it does contain nutrients, but our body's just not able to digest it. So you get some good fiber there, helps you poop. So there's glycogen, carbohydrates, and we already talked about how they're an excellent source. They're an excellent source of energy. A lot of times we start to see the new diets, like one of the big new diets is the keto diet. And what it does is cut out just about all of your carbohydrates, which is not good because the body runs off of carbohydrates. It runs off that simple sugar, glucose, that monosaccharide. That also happened when the Atkins diet came out maybe about 10 years ago. People lost a lot of weight and saw great results with it, but what they also saw is that in some cases, not in all cases, some people ended up going into kidney failure. And that was because the body didn't have any carbohydrates. So what the body is so smart and always wants to stay in homeostasis, it went to grab glucose from another place, which was protein. So it took proteins and transferred them and translated them into glucose. So that took a lot of energy and a lot of stress and strain on the kidney. So some people did end up with kidney failure. Now, let's move to the next thing, lipids. So lipids, we always think of fats, waxes, and oils. We know there are good fats and there are bad fats. Our bad fats are those things like saturated fats, which we usually find in animal products. That would be like bacon and lard, all of those things. Then you have your good fats, which are like fish oils, avocado. I love avocado. Those are your good ones. So you want to make sure that you have a good balance. And as the diet industry continues, it's a multi-billion-dollar industry. Each couple 5 years, they come up with something new that we should eliminate. In the very beginning, I remember as a child, it was eliminate fat. And then we realized that fat is good. You need to have fat. It helps to insulate, it helps to cover and allow it allows things to move along in the body more smoothly, such as different molecules and proteins. And then it became, oh, get rid of carbs. And then it became, get rid of sugar. So depending on what is on the market at that moment is how we fluctuate with what is important. At one point, eggs were really good for you. Then eggs became bad for you. And I think they're good again, maybe. So we have fatty acids, and we'll see more of this once we start looking at the cellular membrane, and I'll go more into depth with the fatty acids. Triglycerides, we always get those checked when you go to the doctor's office. They want to check your triglyceride level to see how many fatty acids that you have there. Triglycerides at room temperature are oils. We have good oils. We have vegetable oil or olive oil. And then you have the bad ones when they're solid. Those would be like lard. The things that I don't know if your grandparents cooked with them, but my grandmother kept a big jar of Crisco and always cooked everything with them. Now, the primary function here, make sure that you tune into this, is energy storage. So not only do we get glucose as the main source, we also can use fat as energy storage. And it helps with shock absorption. So when you get hit or any type of injury, there is fat or padding on your body to help. That is more organic chemistry. We're going to talk about this in chapter 3 a little more, but the plasma membrane, anytime that you see an area that has hydrophobic, and what hydrophobic means is water. Let me see if I can get my tools out here. There we go. I'm going to try to write. Let's see. So water loving. Oh, sorry. Hydrophobic is water fearing. So hydrophobic, any molecules hydrophobic, fears water. So fatty acid tails, it makes sense that they would fear water because we know oil and water don't mix. They do not get along. Whereas hydrophilic, we know loves water. So this is a diagram that we'll see over and over again. So the hydrophilic, meaning loving, so that's going to love water. And here's our fatty acid tails, which hate water because, of course, they're made out of oil, so oil and water does not mix. Cholesterol, very important. It helps to smooth out the plasma membrane, helps it to be liquid so that everything is able to flow very smoothly. All right, here we go. Good and bad cholesterol. We always see Honey Nut Cheerios, and it says have a healthy, happy cholesterol. So they would say there's only one kind of cholesterol, does more good than harm. Good and bad actually talks about the lipoprotein. So we have HDL, that is the happy, healthy cholesterol. You want to have more of that, and that's why Cheerios tells you to have a healthy, happy cholesterol. The LDL is that bad cholesterol that builds up all the fatty acids and all of that that's going on, and that contributes to cardiovascular disease, which is all bad. We've seen the science behind it, and we probably have some loved ones that may be dealing with cardiovascular disease. Proteins, very, very important. They help to make up amino acids. There are several different ones. We'll go through that again more in chapter 3. A peptide bond is what's going to make the amino acids stick together. Here we have dehydration synthesis again, so that you understand that term. Remember, dehydration synthesis means that there is going to be a byproduct of water. And just like the other ones when we were talking about monosaccharides and disaccharides, peptides have about the same thing. Dipeptides, tripeptides, oligopeptides, and polypeptides. Now with proteins, there are 4 different states that they come in. And the way that you can change a protein's shape is by calling it or going through denaturation. When you cook an egg, you start to break down that protein. So they tell you if you eat the egg raw, you get more protein. If you're cooking a steak or if you're cooking a chicken, the more that you add heat to it, you're actually breaking it down. So we have primary structure, secondary structure, tertiary, and quaternary. And as we'll get more in depth in the chapters, we'll go back and look at these. Now, proteins are throughout the plasma membrane. And what we'll see there are glycoproteins, we'll see antibodies, and we know antibodies are so important. Excuse me for Facebook notifications. Cell adhesion, how the cell actually binds to to a different thing. Because remember, we talked about the difference between adhesion and cohesion. And with water, cohesion is when water sticks to water, and adhesion is when water sticks to a tissue or something not like it. We then move into enzymes, which are proteins that function as biological catalysts. So what they can do is help to reduce the activation energy of certain areas, and that helps to speed up the reaction. So we can see here, the energy level of the reactants, we increase the activation energy, and it will move by much quicker if we have a catalyst. Let's skip here. Cofactors and coenzymes are very important because they help to assist with the body. They help, such like vitamins, iron, copper, zinc, magnesium. All these minerals help to keep all of us in homeostasis and to keep all these mechanisms running pretty perfectly. We're going to skip by metabolic pathways and go to the most important of this area, ATP, adenosine triphosphate, best known as, ATP. It has adenine, a sugar, and a phosphate group. That is what we need. That's why we have to have glucose, that carbohydrate, because we need ATP. And we know ATP is made in the mitochondria. So ATP, again, just rehearsing through that. Most important energy transfer molecule. It helps us do work. Sources of ATP, you see that key piece right here, glucose. That's what we always want to start with. And there is stages that we will go through to produce ATP. The very first stage is glycolysis. Then we go from anaerobic fermentation and then aerobic respiration, which requires oxygen. So anaerobic fermentation is usually what you feel after you've been working out for a second. You will see how your muscles start to become really sore. GTP we'll get back to. We don't have to worry about CAMP. And these are the last parts of the genetic information, DNA and RNA, and we'll get more into that for chapter 3. If you have any questions, please email me. Thank you. Have a good evening.